say good morning, but it's like 9:30 at night on the last day of our school, and look what I'm doing. I'm recording videos for you guys. Yay! I know what you're thinking. This guy is... What are you thinking? You're thinking I'm a loser? No! I've got a life. It involves coffee. I'm just kidding, guys. Thanks for coming. I really hope you're getting a lot out of these. You're probably not watching these on a Friday night. I'm doing them on a Friday night because I got to work all day tomorrow with my lifeguard training. Say, all of this information can be found at nkinfinity.com. All right, what you do is you come over here, you see my ugly mug, you see my partner in crime, Miss Vicki Newman, you click on New York State Teachers, and you click on Algebra Review. Now, the ones I'm working on right now are down at the bottom. Just click Regents Review Topics. There's the ones Miss Newman did up in here, and I made the videos for those. And here are some ones I've done that are all geared towards things you need to know. Right now, we're working on this last one, Arithmetic, Geometric, and Recursion Sequences. That's what we're working on. So if you need some stuff, come on down. Here we go. All right, there it is. Now, while you're there, you can just click on the document, print it, and it's all you. You got it. Okay? But if you're doing these problems, if you're not doing these problems on your own, you're faking and fooling yourself. You're not going to get any better just watching the monkey perform. It's not going to happen. All right, kids? So let's get started. So hopefully you've tried these problems already on your own. If you haven't tried these problems already on your own, do it. Please do it. And you're here to watch the video. So you got stuck on these problems. Maybe you got stuck. Maybe you just want to see a different way to do it. I told you the 18th term, and I told you the 20th term. And I told you the 18th term was 10, and the 20th term was 70. We don't know what the 19th term is. We're trying to figure out all the possibilities. So this is always the famous question I ask. What do I have to add to get here? And I have to add that same thing to get here. For an arithmetic sequence, remember, we're adding something, right? So I will say we're going to add x. So 10 plus 2x's has to equal 70. Or 2x has to equal 60. Or x equals 30. Well, if I take 10 and add 30, don't I get 40? So 40 is not going to be one of the answers. Now we're going to do that same process again, but now we're going to do geometric. Now, in order to do geometric, what am I going to multiply by to get to here? And I'm going to multiply that same thing by to get here. Oh, x. That's why I do that. So 10 times x equals 70. Divide both sides by 10, I get x squared equals 7. I divided both sides by 10. Or if I take the square root, I get x is equal to the square root of 7. Oh, no, it's not. It's equal to plus or minus the square root of 7. So now if I take 10 and I multiply by positive square root of 7, I get this. If I multiply by the negative square root of 7, I get this. And there's the one it can't be. Moving on, children. The recursive sequence defined below can also be written as... Well, what I would do with this is just figure out what we got here. We got a sub 1 equals negative 12. Remember, when you're dealing with recursion, this represents the previous term. That's all you got to remember is when you're always doing something with the previous term. So a sub 2 would be equal to negative 2 times negative 12, or 24. A sub 3 would be equal to negative 2 times the previous term, which would be negative 48, and so on and so forth. So, which one of these, if I plug in 1, gives me this term? Well, if I plug in 1 here, I get negative 12 times negative 2. That's 24. That's not going to work. If I plug in 1 here, this is 2. So negative 2 squared is 4. 4 times negative 12 is negative 48. That's not going to work. If I plug in 1 here, I get 6 times, well, negative 2 to the 1 is just negative 2 times 6 is negative 12. Oh, wait, that works. Let's try a 2. I should get 24. Negative 2 squared is 4. 4 times 6 is 24. Ooh, let's try 3. Negative 2 cubed is negative 8 times 6 is negative 48. And there's our big winner. The population for Parma for the years blah to blah respectively were reported as follows. So, how can this sequence be defined recursively? Well, if I want to define it recursively, I cannot use these because these are not recursive sequences. Those were arithmetic and geometric, not recursive. Notice both of these are starting P1 equals 15,700. So now if I take this and subtract this, I should get, I'm thinking I'm going to get 361. It looks like about right. Oops. 16061 minus 15,700. What in the hell is going on here? 16,061 minus 15,700 equals 361. So that looks like it's got a common difference of 361. So now let's try these. 16,431 minus 16,061. Ooh, wait, that's not, it's got to be the same. It's got to be the same. That's not the same. That doesn't make any sense. Maybe that's not it. Maybe this is it. Maybe it's geometric. Let me take this one and divide by this one. 16,061 divided by 15,700. Ah, you son of a so-and-so and such and such. Negative 1.0229. Let's try this one. 16,431 divided by 16,061, period. Ooh, it's really close. Really close. I tried to do the best I can. This was the right answer. If you take 1.023 and you multiply, you get this. If you multiply again, you get this. If you multiply again, you get this. Notice the difference between these two is going to be so drastic. But if I do 17,195 divided by 16,808, you notice, here we go again. You're still at 1.203. That same value keeps coming up. But if I did the difference between those, 17,195 minus 16,808, it's way more than 361. Way more. So this is the better answer. It's not perfect. I could have written a better problem, that's for sure. This problem's, we're going to go into beast mode on this question. So we're going to write the geometric sequence. This geometric sequence formula is on your formula sheet. It's a sub 1 r to the n minus 1. In order to write a geometric sequence, you need the first term and you need the common ratio. First term's easy. The first term is negative radical 2. The ratio, not so much. But remember, the ratio is found by taking the second term and dividing the first term. So if I take the ratio, is going to be the square root of 6 divided by negative radical 2. Well, because these are both in radicals, I can just divide them. So I get negative radical 3, and that's my common ratio. So now I've written the geometric sequence. Oh, crap. I meant to change this. This should say 20th. Doggone it. Sorry, kids. That should say 20th. I'm going to fix this. You know, I should fix it. I'll fix it and send it and I'll update it. Hopefully you're not using the wrong one. I apologize. That was supposed to say 20th. So if I plug a 20 in here, my exponent is going to be 19. So now if I want, I can do this. This is how I'd use my calculator to do this. I'd come over here. I go negative radical 2, negative radical 2, parenthesis, the square root of 3, but it's negative, so don't forget to put that there, negative, raised to the 19th. And you get some of, oh, this is what your calculator is probably going to give you. Sorry, it's not going to give you this. Your calculator will give you that. Oh, here we go again. Why? Don't tell me I need a new computer already, kids. Well, I booted my machine. Let's see if it works. It gives us this answer. I don't know. Hopefully it's working. The mathematical way of doing that one would be the negative radical 2, negative square root of 3. Now, every negative radical 3 times squared is equal to 3. So how many squareds can I get into an exponent of 19? I can really write that as 9 groups of these, right? That would give me 18 with an extra square root of 3. I'm not going to get into it. It's pretty complicated. Let's work on. What's going on? It's going down by half. It's going down by half. So it's going down by 1/2. That means this is a recursive. That means this is a, well, it says we want a recursive formula. So if I want a recursive formula, I can't use this one. And I can't use this one. And since it's going down by 1/2, it doesn't make sense that it's this one. There it is. Start at 18, take half of 18, half of 9, half of 4.5. That one's pretty straightforward. This one here also doesn't require, shoot, I forgot to change this to SWAM. This one also doesn't really require much math. The first day I'm doing 1/5. Day 2 I'm doing 3/5. Day 4, remember, 1 is really 4 or 5 over 5. So 5 over 5 and 4 over 5 is 9 over 5. Remember, whatever. So what am I doing? I'm multiplying by 3, multiplying by 3. But I didn't really even need to know that because notice all of these are geometric. All of these are multiplying. I didn't even mix any arithmetics in there. They're all geometrics. And remember, the geometric formula is a sub 1 r to the n minus 1. Well, how many of them have a sub 1 as 1/5? Just 2 of them. How many have n minus 1 as the exponent? There it is right there. There's your answer. Which of the following will not produce the following sequence of numbers? The sum of the following sequence of numbers. Well, probably what I ought to do is figure out what that sum is. Let's see, that's 21, that's 21, and that's 21. It looks like that's 63. That's just how I would do it. So, I can just type those in to see which one it is. I'm going to do this the right way, though. Plug in 1, I get 3. Plug in 2, I get 6. Plug in 3, I get 9. Plug in 6, I get 18. So, yeah, that one's going to work. Plug in 1, I get 1. Plug in, this is probably the right one. Plug in 2, I get 2. Plug in 3, I get 3. Plug in 4, I get 4. Plug in 5, I get 5. Plug in 6, I get 6. But wait a second. There's a 3 out front. If I add all these up, let's see, that's 10. Well, hold on. That's 7, 7, and 7. That's 21. What's 21 times 3? Oh, that's 63 as well. So that one worked. Plug in 2 here. What's 2 times 3? 6. 6 minus 3 is 3. What's 3? 3 times 3 is 9. 9 minus 3 is 3. And this one would generate it as well. So if you type this one in, it would not give you 63 as a sum. This one is a wicked problem. Wicked awesome. So watch this. My 15th term is 8. 16, 17. My 18th term is 125. So what do I have to add? What am I going to add from there to get to here? From here to get to here, and from here to get to here. That's right, I'm going to add x. But now I'm going to add 3 x's. So 8 plus 3 x's has to come up with 125. Or 3x has to equal 117. Or x equals 39. So if I take 8 and I add 39, I get 47. So I know 47 can't be the right answer. Looks like 50 is probably the right answer because I got 47. But let's see. Oh, man, these answers were not supposed to be here. Oh, maybe they are. So now let's see. So the 16th term could be 39. What would be, if I add 39 again, If I add 39 to 47, I get like 80 something. That's not going to work. So let's try the next one. Let's try a geometric sequence. That would mean I have to multiply by x, multiply by x, multiply by x. So it would be 8 times x times x times x equals 125. Much the same as that problem we had earlier. Divide by 8, I get x cubed is equal to 125 over 8. Now, I didn't write that in as a decimal, and you're going to see why right now. If I take the cube root of both sides, now, with cube roots, you don't put plus or minus, only with square roots. If I take the cube root of that, I get x equals 5 over 2. So now I'm going to go back to my calculator, which I haven't opened up yet. This is probably going to cause my computer to crash again. Sorry. Come on, baby. Let's go. So I take my calculator, view, zoom, 250, and I go 8. 8 times 5 divided by 2, I get 20. Oh, it can be 20. And then I'm going to multiply by 5 over 2 again. 5 divided by 2 again. And I get, oh, it can be 50. So the answer is it cannot be negative 20 because it can be those other ones. Remember, this one's going to be the one that's 20, but this one would be 50. Wait a second. Let me make sure. Multiply by 5 divided by 2. And look at that. I get 125. So there it is. So this question says, write the explicit formula for this. I'll be right back for that. All right, so what they're saying is, I gave you the recursive one. I want you to write the explicit. So you need to write an arithmetic or a geometric sequence. You have to decide which one. Well, notice what's happening. I'm taking 2x and I'm multiplying it by the previous term. Well, multiplying is geometric. So I know my formula for geometric is a sub n equals a sub 1 r to the n minus 1. Well, there's a sub 1. I just got to figure out what r is to the n minus 1. Well, remember, r is equal to a sub 2 divided by a sub 1. Every single day, all day long. So a sub 1 is, x plus 3. Now, I don't know what a sub 2 is, but look what I can do. If I want to know a sub 2, I'm just going to plug this in. And that'll give me, so it'll be 2x times x plus 3. And don't these cancel? So there's my ratio right there. So 2x. Now, a lot of kids would turn this in as the answer, but it's not the right answer. It's really close. Remember, the formula is the first term times the rate raised to the n. Well, that's not what's going on here. This is only 3 times this. In order to get the first term times, that had to be in parentheses. Get in a good habit whenever you see a binomial to put it in parentheses. All right, if you downloaded this before I changed this problem slightly. Oh, and I don't have this formula. Do I have this formula? Formula sheet. Nope. I'm going to find it. There it is, formula sheet. So we're going to use this formula right here. Actually circled for us. We're going to use this formula right here. So let me go back to lunch reviews. And that formula is S sub n is equal to a1 minus a1 r to the n all over 1 minus r. And there's only one tricky part about this. So my a sub 0 or a sub 1 is 26,750 minus 26,750. Now, it is a growth rate. So I need to put 1.0475 to the n. 1 minus 1.0475. See, most kids are going to forget about this 1. If I didn't put the 1 in there, that would be decay, and I'd be losing money. So it says use your formula to determine how much money she's going to make for the 14th. So I'm going to do S sub 14. Write this out. Make yourself look good. 26,750 minus 26,750, right? 1.0475 to the 14. 1 minus 1.0475. And we'll grab the old calculator. Control division. So 26,750 minus 26,750 parenthesis 1.0475 parenthesis raised to the 14 all over 1 minus 1.0475. Now, you should get some pretty good money, right? It's $26,000 a year for 4 years, plus interest, plus increased salary. There it is, $512,000 or $515,000. $258.84. So now I want you to write a summation expression that can be used to determine the total earnings for 14 years. So this one's going to be a little bit different. I now can't write that, I can't use that formula. So I'm going to write a summation formula. Now notice, what am I doing? I'm multiplying by a growth factor. That is a geometric sequence of numbers. So I'm going to add up the geometric sequence of numbers. So it's 26,750, 1.0475 raised to the n minus 1. Isn't that the geometric sequence formula? Remember, all of this has to be in parentheses. That's the geometric sequence formula. That's what I did. So that's what I'm going to do in my calculator. I'm going to come over to my calculator. Hello, calculator. I'm going to go down here into escape. I don't want that. I want to go click on this, and I want to click on this E right here. And it's in the other calculators as well. N1, 14, and what do we got? 26,750, parenthesis, 1.0475 raised to the n minus 1. So that's my geometric formula, and we're going to do a summation of the geometric. So basically, here's year 1, here's year 2, here's year 3, and we're just going to do a summation of those. We click enter, and we get the exact same value. All right, kids, almost done. A couple more problems. So since most kids hate recursion, I thought I'd show you, goodbye Cortana. I thought I'd show you all the different kinds of things for recursion, okay? So this first one, remember, recursion is generally doing something with the previous term. So in this case, a sub 1 is equal to 4. A sub n, well, they're saying a sub n plus 1. Don't get confused by that. It's really a sub 2. A sub 2 is equal to 3 halves times the previous term, 4, plus 10. And I want to do the fourth term. So this is 2, 6, 16. So now I'm going to do a sub 3 is equal to 3 halves times the previous term, 16, plus 10. 8, 24, 34, 34. And finally, the last one, a sub 4 is equal to 3 halves times the previous term, 34, plus 10. 17, 51, 61. So that would be 61. Now again, if you just put these in your calculator, you get it. Now let me show you how the calculator can do this really, really, really nicely for you. And that won't work for one of these examples, 2 of these examples, but it'll work for the first 2. It won't work for the last 2, but it'll work for the first 2. You come over here and you type in the first number, which is 4, and you just press enter. Now what's the thing say? 3 halves. 3 divided by 2 times, and you go control answer. 3 halves times the answer, and press enter. 6. Oh, I forgot the plus 10. Doggone it. 4, enter. 3 divided by 2 times the answer, plus 10, enter. And enter again, 34, enter again, 61. Great tool. Great. Does recursion beautifully. Let's do this one. It'll work for this one as well. A sub 1 is equal to 320. a sub 2 is equal to, it doesn't matter what these look like, it just means the previous term. You know, if I'm on n plus 1, if I'm on the n plus 1 term, isn't the n term just the previous term? That's all recursion means. Do something with the previous term. So 1/2 times the previous term, which is 320, plus 32. 160, 192. 192. So a sub 3 is equal to 1/2 times 192 plus, my computer's just killing me today, kids. Sorry. It's like back to my laptop days. Half of 92 is 96. We'll just do it on the calculator. So this is probably, I think it's I think this is 128. Oh man, my computer's just dying on me. So now I'm going to do a sub 4 is equal to 1/2 times 128 plus 32. 64, that's 96. And a sub 5 is equal to 1/2 times 96 plus 32, 48. I think that's 80. Now let's check using the calculator. Hopefully my computer will not die. It's like it's running out of memory or something. I don't know what's going on. So again, I'm going to use recursion. So I'm going to type in 320, enter. I'm going to do 0.5 times, that's 1/2, times the answer, plus 32. 192, 128, 96, 80. There it is, kids. You can retype all that stuff in, but that's nice. Now, this one, not going to work that way. It's just not going to work that way. You can't do it. So this one, we got work to do. So, a sub 1 is equal to 2048. A sub 2 is equal to 1024. A sub 3 equals, we just got to suffer through these last two questions, and hopefully I can fix my computer and it doesn't die on me. All right, so a sub 2. Now this is going to be interesting. This represents one previous term, -1. This one represents two previous terms. So when I come over here, I'm going to do -1/2 times one previous term, which is 1024, minus 1/4 times two previous terms, which is -20, which is just 2048. So that one I got to put in my calculator. -1/2, -1 divided by 2. I apologize for this computer. I don't know what's going on. 1024. Maybe we should make some donations so I get a new one. It's driving me crazy. Minus 1 divided by 4, parentheses, 2048. So -1024. So now I'm going to do a sub 4, which is equal to -1/2 times the one previous term, -1024, minus 1/4 times two previous terms, 1024. Now I'm going to do this. Negative 256. Now finally a sub 5 is equal to -1/2 times one previous, 256, minus 1/4 times two previous, -1024. 128. So the answer is 128. All right, finally, last problem. Woo! Hopefully. Now, you'll notice this has got a weird thing at the end here, but that's okay. Don't let that sweat you out. A sub 1 is equal to 3. Recursively, a sub 2 is equal to negative 2 times the previous term, negative 2 times 3, plus n squared. Well, this is n right here. So in this case, n is 2. So plus 2 squared. So that's negative 6 plus 4, negative 2. Now a sub 3 is equal to negative 2 times negative 2 plus 3 squared. That's 4, 9, 13. Now a sub 4 is equal to negative 2 times 13 plus 4 squared. Let's see, that's negative 26 plus 16 would be negative 10. And finally, a sub 5, last problem, and just in time for my computer to croak, negative 2 times negative 10 plus 5 squared, which is 25. And that is 20 plus 25, which is 45. And that would be the answer to this question. All right, kids, I apologize for all those I don't know what is going on with my computer, but hopefully I'll figure it out because I got some more videos to shoot. Catch you all on the flip side. Goodbye.